The seating availability monitoring system is addressing safety management is growing in the restaurant industry to streamline operation, booth review, and extend dining experience. The seating availability tracking system sets use real-time data, advanced sensor, wireless network, and automation to address seating challenges innovatively. The set provide accurate seating availability insight enables restaurant staff to make informed decisions and improve operation efficiency. While the objective of the seating availability monitoring system is to monitor and manage seating availability in a restaurant, cafe, food court, and other venue. It provides real-time seating availability and utilization information through effective resource optimization and management. It limits the number and dinner to the established maximum capacity, which is nowadays we must go to the restaurant to see if the restaurant full or not. So with our project, we don't have to go to the restaurant, so we can just see through the apps or see outside the restaurant.
Problem statement. First one, overcrowding in bars, cafes, and restaurants post-pandemic has highlighted the need for efficient crowd control and seating management to prevent resource waste. Number two, a seating monitoring system addresses these challenges by providing real-time table availability updates, enhancing the dining or seating experience for both staff and patrons. And the last one, the system helps optimize staffing, improve customer satisfaction, manage time effectively, and ensure the best use of seating through accurate occupancy tracking. For the flowchart, it will be start, door open, dinners entering the restaurant, dinners moving to the seat at the table, and it will update the dinner count, which is +1. It will send instruction to display the number of seats occupied. Then it will send instruction to keep the door open. The maximum occupancy will be reached at 5. If the maximum is not reached, so it will send back the instruction to keep the door open. If it reached, so the instruction will say yes, and will be sent to the instruction to close the door and end the
So
flowchart.
now I will explain more about method for this project. There are 7 methods. Number 1 is the assigned computers EZ68K software was successfully installed. Number 2, to generate a new project file, especially for this assignment. Number 3, the editor was used to design and enter program code. Number 4, the assemble button or the F9 keyboard shortcut were used to start the program's assembly. Number 5, the simulator was turned on by clicking the execute button once the assembly was completed successfully and error-free. Number 6, the program was simulated in the simulator, which accurately mirror how it would run on the 68K training kit. And the last is the simulations result were thoroughly documented for later examination and analysis. I will explain more on conclusion. So, in conclusion, a seating availability monitoring system can greatly enhance a restaurant's operational efficiency and customer satisfaction. By leveraging modern technology, it provides real-time tracking of table availability, reduced wait times, and improved service flow. Features like reactive doors ensure seamless admissions and maintain optimal dining capacity, creating a welcoming atmosphere. The system's transparency allows customers to make informed decisions, while its automated functionalities streamline operations. Together, these innovations enhance seating arrangements, optimize service, and leave a lasting positive impression on patrons. That's all.
Assalamualaikum and good evening. I'm Nurul Iza binti Maslizam from 3BELG S2. My matrix number B0122101115. I would like to explain briefly about this coding system to our project, which is seating availability monitoring system. This assembly code simulates the behavior of a system where diners move within a restaurant environment with doors opening and closing based on specific condition. It uses movement, logic, condition, and subroutine calls to manage the state of diners and doors. Key section. Firstly, initialization, setup initially position for doors, door 1 and door 2, and diners, dinner 1 to dinner 5. Coordinates are defined for each entity. We use as X1, Y1, X2, and Y2. This we can see we use the coordinates as defined. Next, we use main loop. The program continuously loops to update the position of the dinners and doors. Call subroutine to draw display and manage the screen updates. So we can see here, we have loop JSR topic, JSR draw status box, JSR draw restaurant, JSR draw tables, JSR draw door 1, JSR door 2, JSR display. So, the screen will update by using the loop. Next, we have a dinner movement, which is condition 1 to condition 8. So this coding we use from condition 1 until condition 8. So we can see here. Just take a time. until here. So use conditionally branch, which is TMPI, BGE, and BLT to check counters D5 and D6 and determine the movement of diners. Movement are defined as condition or subtraction to X or Y coordinates, simulating directional movement, right, left, up, or down. So we can see here, we use this one, like this one, add immediate value to make diners to move to the right. So like this, condition 7, we have add immediate value to make diners to move downward. So at condition 6, we have add immediate value to make diners to move to the right. Next, we have a door operation. We have opening. The door gradually open. For example, the 1 move left, door 2 move right over 14 steps using a counter D5. So we can see we use subtract the immediate value to make the door 1 open, move to the left, and then at the door 2 open, move to the right. So when the door open loops, so it will be moved in the same time, and then it will make a door open. Next, we have closing, door return to their initially position, again using incremental movement. So the door close loop is back to the normal condition, which is before the door open. Next, we have a display update. Text and status are updating using subroutine like display status 1 and status 2. Message indicate dinner's counts and door state. So we can see here we use display, display 1, display 3, and display 5. Next, we have subroutine. Drawing subroutine like draw dins 1, draw door 1, and handle graphical rendering of dinners and doors. Screen management includes delay. We use delay. Um, it- we can see here. I'm sorry. Yes, this one. We use delay. For 5, um, a second delay. Then we have using clearing clear screen and updating the display. Next, we have exit condition. The loop terminates when all step, door, and dinner's movement are complete. We use this one, simulation. Next is why we use the move.l instruction, because it's a fundamental part of assembly language for the 68K family of microprocessor. It is used to transfer data from one location to another. We can operate the transfer data from a source to a destination. Specify the size of the data being moved. In this case, L stands for long word, 4 bytes or 32 bits. How about move.b? So if you can see here, sorry, move b is move a byte 8 bits. For example, move b d0 d1, move 8 bits from d0 to d1. Next, we have move.w. Like here, we use move.w. Is move a word 16 bit. Move.w. For example, A0 to D2, move 16 bit from memory at A0 to D2. Next, we have move.l is long word. As you can see, we use more move.l because, for example, we have a move 32 bits to memory at A all. Data register to register. Transfer data between data register. Example D0, D1. Example move.l, D0, D1. Next, we have memory to register. Transfer data from a memory address pointed to by an address register to a data register. Example, move.l, A0, D1. Next, immediate value. Loads an immediate constant value into a register. Example, move.l, hashtag 10 to D1. Register, lastly, we have register to memory. Store data from a register to a memory address. Example, move.l, D1 to A0. So, purpose is the system help optimize setting arrangement by providing real-time update on available occupied and reserved seats in its and enhance user convenience and operational efficiency. Like the coding works, how coding works by position and status of a seat or table are predefined in the system. Each seat or table is assigned a specific location coordinate like X1, X2, Y1, Y2. Next, monitoring. The system continuously check the status of each seat, sensor, pressure infrared, detect whether a seat is occupied, manual input or software log change. For example, reservation or empty seat. Lastly, we have data update. Change are reflected in real time with movement and status display visual on a screen or dashboard. So we use another coding for a color. So if we execute this coding and we run this coding, so you can see no errors set. So we can execute the program. Okay, and then you can see here we have a green light. So we run, and then we can see the result. This is how the result produced by this coding when diners sitting have reserved or no, and the door open and closing. Okay, so the status box will mention, and then the update we use we are fully occupied. Please wait for the next round. Thank you. And we can see here terminate train and read file read successful. That's all from me. Thank you.